Multitasking can be of two types, process based and thread based. Multitasking threads require less overhead than multitasking processes. Processes are heavyweight tasks that require their own address spaces. Inter-process communication is expensive and limited in process-based multitasking. Context switching, that is, switching from one process to another, is also costly. Threads, on the other hand, are lightweight. That is, they share the same address space and cooperatively share the same heavyweight processes. Inter-thread communication is inexpensive and context switching from one thread to the next is of low cost. Multithreading enables you to write very efficient programs that make maximum use of the CPU because idle time can be kept to a minimum. So, a multi-threaded program allows multiple operations to perform at once and hence it saves the time of execution and it can be run independently. Multi-threading in Java covers three main topics. The first one, how to create a thread. Second one, life cycle of a thread. Third one, synchronization of thread. The threads in Java can be created by using two ways. The first way is by using a thread class and second way is by using a runnable interface that we see later. Each thread will be assigned with priorities and these thread priorities are integers that specify the relative priority of one thread to another. A thread priority is used to decide when to switch from one running thread to the next. This is called context switching in the scenario of a multi-threading. And the rules that determines when a context switch takes place are simple. First one, a thread can be preempted by a higher priority thread. That is, a lower priority thread that does not yield the processor is simply preempted, no matter what it is doing, by a higher priority thread. This is called preemptive multitasking. Second is, a thread can voluntarily relinquish the control. That is, it can give the control by moving into a sleeping mode to a high priority thread that is ready to run and it is given the CPU. The life cycle of a thread. The life cycle of a thread contains the following state: newborn, running, runnable, dead, blocked. A thread is said to be in newborn state if you can create an instance of a thread class but before the invocation of the start method. Once a start method has been associated with the new thread, it moves to the runnable state. A thread is in runnable state after invocation of a start method, but the thread scheduler has not selected it to be the running thread. That is, the particular thread is ready to run, but it has not given the CPU. Once it gets the CPU, it moves to the running state, or the thread is in running state if the thread scheduler has selected it to execute. Then we have blocked state. In blocked state, the thread is actually alive but is not currently eligible to run. That is, it has been temporarily made to wait. This can be made possible by invoking the methods like suspend, sleep, and wait. So, when a running thread is invoking a suspend, sleep, or wait, then that moves to a blocked state. And from the blocked state, it can move to a ready state by calling the methods notify and resume. So a blocked thread can be moved to a running state by using the methods notify and resume. And if the thread is associated with a stop method, the thread moves to a dead state or a terminated state. A thread is in dead state or terminated state when its run method exists. The main thread. When a Java program starts up, one thread begins running immediately. This is usually called the main thread of your program because it is the one that is executed when your program begins. The main thread is important for two reasons. First one, it is the thread from which other child threads are created, and often it must be the last thread to finish execution because it performs various shutdown actions. Although the main thread is created automatically when your program is started, it can be controlled through a thread object. To do so, you must obtain a reference to it by calling the method current thread, which is a public static member of thread class. Its general form is static thread current thread. This method returns a reference to the thread in which it is called. Once you have a reference to the main thread, you can control it just like any other thread. Next is the syntax for set name. So once you have control of a thread, you can rename the thread. The syntax is final void set name, then string thread name, or final string get name for getting the name of the thread. A thread can be made to sleep by invoking the sleep method, and the general syntax or general form of the sleep method is static void sleep long milliseconds throws interrupted exception, or static void sleep long milliseconds comma int nanoseconds throws interrupted exception. The second form is useful only in environments that allow timing periods as short as nanoseconds. The sleep method causes the thread from which it is called to suspend execution for a specific period of milliseconds. As mentioned, often you will want the main thread to finish the last. For that, sleep method will be called within the main method with long enough delay to ensure that all child threads terminate prior to the main thread. How can one thread know when another thread has ended? Fortunately, thread provides a means by which you can answer this question. Two ways exist to determine whether a thread has finished. First, you can call isAlive on the thread, and this method is defined by the thread class and its general form is final boolean isAlive. The isAlive method returns true if the thread upon which it is called is still running, else it returns false. While isAlive is occasionally useful, the method that you will more commonly use to wait for a thread to finish is called join. The general syntax is final void join throws interrupted exception. This method waits until the thread on which it is called terminates. Its name comes from the concept of the calling thread waiting until the specified thread joins it. Additional forms of join allow you to specify a maximum amount of time that you want to wait for a specified thread to terminate. Synchronization. When two or more methods need access to a shared resource, they need some way to ensure that the resource will be used by only one thread at a time. The process by which this is achieved is called synchronization. The key to synchronization is the concept of the monitor, also called as semaphore. A monitor is an object that is used as a mutually exclusive lock. Only one thread can own a monitor at a time. When a thread acquires a lock, it is said to have entered the monitor. All other threads attempting to enter the locked monitor will be suspended until the first thread exits the monitor. These other threads are said to be waiting for the monitor. A thread that owns a monitor can re enter the same monitor if it so desires. You can synchronize your code in two ways. Both the ways involve the use of a synchronized keyword. The first way is by using synchronized method. Second way is by using synchronized statements. using synchronized methods. Synchronization is easy in Java because all objects have their own implicit monitor associated with them. To enter an object's monitor, just call a method that has been modified with the synchronized keyword. While a thread is inside a synchronized method, all other threads that try to call it or on the same instance have to wait. To exit the monitor and relinquish the control of the object to the next waiting thread, the owner of the monitor simply returns from the synchronized method. The code snippet is shown the synchronized statement. While creating synchronized method within classes that you create is an easy and effective means of achieving synchronization, it will not work in all cases. To understand why, consider the following. Imagine that you want to synchronize access to objects of a class that was not designed for multi-threaded access. That is, the class does not use synchronized methods. Further, this class was not created by you but by a third party and you don't have access to the source code. Thus, you can't add synchronized to the appropriate methods within the class. How can you access to an object of this class be synchronized? Fortunately, the solution to this problem is quite easy. You simply put calls to the method defined by this class inside a synchronized block. This is the general form of the synchronized block, that is, synchronized object. Curly braces. Within the curly braces, you have to write the statements to be synchronized. Here, object inside the keyword synchronized is a reference to the object being synchronized. A synchronized block ensures that a call to the method that is a member of object occurs only after the current thread has successfully entered object's monitor. The interthread communication in Java is made possible via the methods wait, notify, and notify all methods. These methods are implemented as final methods in object class. So all classes have them. All three methods can be called only from within a synchronized context. Although conceptually advanced from a computer science perspective, the rules for using these methods are actually quite simple. First one, wait. The wait method tells the calling thread to give up the monitor and go to sleep until some other thread enters the same monitor and calls notify. Second is the notify method. Notify method wakes up the first thread that called wait method on the same object. Third is notify all. Notify all method wakes up all the threads that called wait method on the same object. The highest priority thread will run first. And all these methods are declared within object as shown as below. Final void wait throws interrupted exception. Final void notify and final void notify all.